Hi all, and we're going to talk today about graphing linear inequalities. This is the last topic that will be on the quiz tomorrow. So as a reminder, you have a quiz on Tuesday this week, which I've been giving you reminders about for the last week, but this is hopefully your last reminder, and no one is surprised. If you are surprised, get in touch with me. You have a quiz on May 11th tomorrow. So get yourself ready for notes, and we're going to get started. So we're going to talk about graphing linear inequalities, and we're going to start by just reminding ourselves how to graph basic inequalities. So for number one, it says graph x is less than or equal to 4. So with graphing up till now, we've just been using the number line. We're going to use the coordinate plane for the new ideas in this unit. And what we always start with is that we plot what I think of as the boundary. And so that's, right, that's this number here, right? This is the boundary. And we'll plot it on our number line, in this case, 4. And then we have to decide if that boundary is open or closed. Now remember, it's open means that it is an unfilled in circle, and that's when it's less than or greater than, and it's closed if it's a filled in circle, and that has the or equal to. So in this case, we have a closed boundary here, which means we're going to fill in that circle. And then our last part is that we shade all possible answers. So in this case, x can be any number that's less than or equal to 4. So that's why we shade 4, because x could be 4. And then we also shade in all the numbers that are less, because all those numbers could be x as well. So again, boundary, open or closed, shade the possible answers. Now, we are going to use this exact same method for graphing number 2. So in this case, we are still going to start with plotting our boundary. Now, since it is not a point on a number line, but you'll notice something on the graph, that is just the mx plus b, slope-intercept form, because we're going to plot a line. Now you'll notice here we have our slope-intercept form. We have slope -4 over 5. So rise is -4, 5 is our run, and we have a y-intercept of 2. So if I'm going to plot that line, I go plus 2 here on the y-axis, and then I would count down 4 and over 5 for the rise and run. So my next point is going to be here at 5, -2. Now, we still have to ask our question. Before I draw my line, I have to ask the question, open or closed? Now with a line, a closed line is just going to be a solid line. An open line would be a dashed line like this. So you'll notice here we have just y is less than. So that means that we are looking at an open boundary. So instead of drawing a solid line there, I am going to draw a dotted line through those points. So that's my boundary. I've decided if it's open or closed. The last question I have to answer is I have to shade all the possible answers. So either I'm going to shade this section below the line, or I'm going to shade this section above the line. Now in this case, I look at y is less than. So if I'm thinking about things where, I'm going to use blue still, where y is less than, I'm going to start at my point here. Y is this axis, this is less than. These are our negatives. So this is the side then that I end up shading. And I'm just going to take my pencil. It doesn't have to be perfectly neat. What I'm doing here is just fine. Shade it in so that it's just clear which side the possible answers lie on. So the idea is that I could plug in any point in this region. If I plugged it in here, the inequality would be true. Let's look at another example. So number 3 says graph y is greater than or equal to 2x. So what this tells us is our slope is 2. Since there isn't a plus anything, that means that b is 0. So slope is 2 over 1 for our rise and our run. So I'll start at our y-intercept 0 and then up 2 over 1 for our next point right here. So that's where our boundary is going to be. If I look at the inequality sign, this is a closed inequality sign. So that means I'm going to use the solid line here. So no dotted line. I find it really helpful with these ones to draw the line all the way from the edge of the graph. Takes a little bit of careful practice, but then it makes it really clear where the boundary, where the shading needs to be, because we have 1/2 here and 1/2 here. In this case, y is greater than 2x. So again, I'm going to start at my y-intercept, and greater is this side. So that means that this is the side that needs shading. So up to the boundary, a little bit over it, I'm a little bit messy, that's all right. You can go through with your eraser. And this is the region that we should be shading. Now, sometimes you won't have to graph it. Sometimes we'll just have to answer questions about these linear inequalities. So tell whether the point -3,9 is a solution to the inequality. So as I said, any point here would be a solution for this inequality. Any point in this region would be a solution for the inequality in number 2. Now, you could graph out this problem in number 4, or you can just plug in the numbers and see if the inequality holds. Because what this lets us know here is this is our x value and this is our y value. So when I put those into our inequality, I would say that 9 is greater than 2/3 times -3 plus 11. Now the question is just, is this true? If it's true, it's a solution. If it's not, it isn't. So here we're going to do our arithmetic. -3 times 2/3 is, you could write as -6/3 plus 11. So 9 is less than -2 plus 11. So this has ended up with the question, is 9 less than 9? No, this is not a solution to the inequality. Now, if this had been a closed boundary here, that would have been a solution. Here we have a couple of word problems. The sum of 2 consecutive numbers is less than 40. What is a pair of integers with this property? Whoop. Now, this is true for so many numbers. So many numbers have a sum of less than 40. But let's make sure that we're all defining what consecutive means here. Consecutive numbers are numbers that are in order. So if you ever see consecutive, that just means in order. So an example would be 7 and 8. Whoop, I wrote 9. 7 and 8 are consecutive. 2 and 3 are consecutive. -7 and -8 are consecutive. And what's the important idea here is that whatever the first number is, the next number is just one more than that. So here, what is a pair of integers, a pair of whole numbers with this property? 3 and 4 are less than, have a sum, meaning that they add up to less than 40. 10 and 11 add up to less than 40. You can pick any number you want. Also negatives, of course. -7 and -6 add up to less than 40. All of these would be a fine set. You can make up your own if you like. Now for 6, it asks, what is the greatest pair of integers with this property? And so what you want to do is, I'm going to write an inequality for this. So I'm going to use this fact here, where the first number that I'm trying to find is x, and the next one is x minus 1. X plus 1, excuse me. And it's their sum. So this would be the two consecutive numbers, and this means that it's their sum. We then know that it's less than 40. So I'm going to use the less than 40. And then this is the problem I actually want to solve. So x plus 1 is less than 40. I'm going to start by combining like terms to say that the 2x plus 1 is less than 40. Subtract 1 on both sides. 2x is less than 39. When I divide by 2, I find that x has to be less than 19.5. Now, if x is less than 19.5, that means that the largest number, the greatest number, that's still less than 19.5 is 19. So that means that the first number is 19, following the rules of consecutive numbers. The next one would be 20, so the final answer would be 19 and 20. All right, we've seen a couple of things, more advanced ideas with inequalities. Please let me know if you have any questions, and please come to the Zoom if you do. I can't wait to hear from you all.